Problem F17-9. At the instance shown, the uniform 30 kilogram cylinder rod has a counterclockwise angular velocity of omega equals 6 radians per second. Determine the tangential normal components of the reaction of pin O on the rod and the angular acceleration of the rod at that instant. Let's start by drawing a free body diagram. So we're going to have a vertical reaction in the y direction, a horizontal reaction in the x direction. There is a moment of 60. There is the center of gravity, mg, down. And I think that's it. So let's sum the forces in the x direction first. So in the x direction we have OXY, or ROX, and that is the only other force. Now the center of gravity is rotating, therefore we have a centripetal acceleration back. So and actually it looks like I probably drew this the wrong direction because it's the only reaction that's going to be equal to that centripetal. So this is equal to m omega squared rho, which is 30 times 6 squared times the distance between the point and the center of gravity, which is, this is 0.9 all the way across here. That's so the center, that's going to be 0.45. So the difference is 0.15. And so RO in the x direction is going to be 162 newtons in this direction. So if we sum the forces in the y direction now, we get ROY minus mg, ROY up, mg down, and that'll equal to the mass times the acceleration of the center of gravity in the y direction. So ROY minus 30 times 9.81 equals 30 A in the y direction. So ROY minus 294 equals 30 A in the y direction. We can't solve this, we have two unknowns, so let's move on to summing the moments. So if we sum the moments about O, we get 60 minus, so 60 is a moment, positive, mg down, mg times the distance 1.5, or 0.15, and that's the only thing we have causing moments about O are the two reactions that go through it, so it doesn't matter. And so that will be equal to I alpha, I about O. This is a cylinder rod, and the moment of inertia of a cylinder rod about the centroid, according to the back cover, is 1/12 ml squared. And then we don't want it at the centroid, we want it at O, which is 0.15 off. So using the parallel axis theorem, we get the mass times the radius squared, or the distance squared. So the mass is 30, and the distance is 0.15 squared. So putting 30 into there, and the length of 0.9 into there, the moment of inertia is 2.7. So putting that into the equation there, and mass and gravity into there, we get 60 minus 30 times 9.81 times 0.15 equals 2.7 times alpha. So alpha is equal to 7.85 radians per second squared. A is equal to alpha r. Therefore, alpha is equal to A over r. And in this case, no, we want to find A. So putting 7.5 into alpha and putting 0.15 in for r, we get A equals 0.883 meters per second squared. Now putting this into this equation up here, we can solve for r, and r, o, and the y minus 294 is equal to 30 times 0.883, and r, o, y is equal to 321 newtons. That's it.